this is Math 2270 coming to you from the College of DuPage during the summer of 2020, and this is the conclusion of the lecture entitled Introduction to the Laplace Transform. When last we concluded, you were finding the Laplace transforms for these given functions. I hope you finished this, but just in case you didn't, I'll give you a chance. You know what to do. Let's see how you did. Well, we know it's a linear operator, so the 6, the 1, the 5, and the -9 just sit there, and so we're going to be using things from our table. So we know the Laplace transform of 1 is this, the Laplace transform of e to the at is this, and the Laplace transform of t to the n for t an integer is this. And so that's what we substitute in, and we simplify it just a bit. Now I should note, before you go trying to simplify this a lot, what you're going to do in the end game is find the inverse transform of this, so you want this to line up with things that are in your table. So in these problems, I'm not going to be simplifying this more because as we go forward, that's just work we would have to undo. This one, again, it's linear, so the 4, -9, and 2 just sit there. We're going to use formulas 7 and 8 from our table to take the transforms, and this is what we get for our answer. Here's problem number C. Note that this is the hyperbolic sign, not the sign itself, and that is of course different, and so that's formula 17, and the other formula we need is number 7. So the 3's just sit there, and we substitute values from our formulas, and we get this as our final answer. Again, the 1, and the -1 just sit there. We've done this before. This is going to be formula 2. We've done this before. This is going to be formula 8. We have not done this before. This is formula 20, and so I get that. So I substitute in directly from that, and this is what I get for my answer for this one. Here's some more problems. There's 5 more, I guess. We want to find the transform of each of these functions. These are a little bit more involved. So invest some time in these, and then we'll look at a solution. You know what to do. Let's see how you did. Now this function isn't in our table, so we have to do something else. But we can use number 30, and number 30 is up here, and it tells us what happens when we take the transform of t raised to the nth power times f of t, and this is what we get. Now notice that this is -1 to the nth power, and this is the nth derivative of the transform with respect to s. Okay, so what happens here is then the transform of this f of t is f of s, and that's the transform of this, but g of t in this case is the cosh, and the cosh formula is found in formula 18, which is down here, and this is going to be by formula 30 minus, this n is 1, and that is the first derivative of g of s. But g of s is this. We're taking the derivative of this with respect to s. We use the quotient rule and simplify, and we get this. So using 30, we have this is our answer. I guess we used 30 and 18. Here's problem B. Again, this isn't in our table directly, so we use number 30 in our table. And we could use number 30 in 2 ways. We could use it with n equal 1, and we could have one t stripped off and the other t sitting here with f of t, and we were taking a first derivative of the transform of f, but that would be taking a product rule t sine of 2t, or we could use it with n equal 2. And if we do it with n equal 2, we would have t squared f of t, but now f of t would be this, and you would have to be taking the second derivative. We're going to do just the first derivative. You should try it the other way, I suppose. So using formula 9, and here is formula 9, it says the transform of this is this, and again we're letting f of t equal that here. So we're going to get f of s is this. We take the first derivative of that and simplify it. That of course has to be the quotient rule, and we get this, and we have to have another minus because there's another minus in the formula, and so this is what we get as our transform of problem B. Here's problem C. Now this part can be done either with number 6 with n equal 2, and by the way that's directly n equal 2. You could write this directly if you saw 6, but we're going to use problem 32, or not problem 32, property 32 over here to do this, and along with 5, and this is 5 that you see here. So in order to use 32, we need to notice that if you integrate from 0 to t, the square root of v dv, we're going to have t raised to the 3/2 divided by the new exponent, which is going to be 2/3 when you bring it up to the numerator, minus, and then when you put 0 in, you're going to have 0. So we have that. That means if we solved for this, we would have t to the 3/2 is 3/2, that is this integral. But you see this integral, when you take the transform, is just f of s over s. And so we know that then that this is going to be where f of t, which is the thing we're integrating here, is the square root of t, or square root of v, then f of s is this, and we know that the transform then is just going to be that divided by s yet again, and so what we're going to get is this. We have to multiply by the 3/2, and then we divide by s again, and that's what we get as an answer. Here's problem D. For this part, we're going to use number 24. Number 24 is a scaling factor, so if we take f of ct, and we take the transform of that, that's 1 over c times the transform of s over c. And so we're going to apply that to the previous problem. The previous problem we had, what was the transform of t to the 3/2, and we got that was g of s is this. So we're going to combine those two. So here we have f of t is equal to g to the 10t. So you see we're letting c be 10 in that problem. So the transform then is going to be by this property up here, number 24. It is that. And then I'm going to use my previous thing. I'm just going to substitute s over 10 in for t, and I get this, and I simplify a bit, and I get this. Make sure you understand that simplification, but yes, you will get that. And here, the final one, I think, we have t times g prime of t. Now we're again going to use number 30, and number 30 is down here. But we're also going to use 35, which says if I take the transform of the derivative, if I integrate by parts, I get this as s of f, capital F of s, minus f of 0. This is really integration by parts. But f of 0 is a constant. So whenever we take this transform, we're going to get immediately, using number 30, this. But then the transform of the derivative is going to be this by property 35. Take the derivative with respect to s, but this is a constant, so that is going to be 0. And the derivative of this with respect to s is going to be the product rule. So it's 1 times g of s plus s times g prime of s. When I simplify it, I get this. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now, more than ever, take care of yourself and of each other. God bless you all.